Hello, my name is Alex Carver. I'm a Senior Solutions Engineer with Pure Storage, primarily covering VMware products and integrations. Now, continuing with the vVols 101 series, let's go ahead and cover what are vVols. One of the common parts where people are referencing vVols is, well, am I referencing the actual individual vVol themselves? Am I referencing the kind of what vVols are, that vSphere virtual volumes from that high-level view? Or kind of what am I referring to? And so generally when speaking, when I say, hey, this VM is on vVols, or hey, does this array support vVols, or this environment using it? It's just kind of that high-level view. Is virtual volumes being employed there? When I'm referring to an individual vVol, that's referring to the individual object on the array itself that maps directly to a VM's virtual disk or the configuration of the VM. So one way to look at this is to look at your VM and the way it looks when it's deployed with vVols. When I first either storage vMotion a VM to vVols, or when I create a new one or a deploy from template, however the VM's created there, first thing that happens is a configuration or a config vVol is created. And when that config vVol is created on the array itself, a volume is created that's named aptly config. And so what this is it's a kind of a mini VMFS partition. So basically it's a 4 GB sized volume on the array that VMware then goes ahead and formats with VMFS. And this is where that logical collection of the files for that VM and its configuration are then stored. So if I went and browsed a vVol data store and I found the VM, essentially that is looking at this file system and those files there. Then when I start creating virtual disks for this VM, in this case, we created a 100 GB virtual disk. Well, on the array, vSphere tells the array we need a data vVol. So a new virtual volume is created with a data vVol type. And it's sized to whatever the size of the virtual disk was. So in this case, 100 GB. And so this is a raw device. It's not formatted with VMFS. It doesn't have a VMDK encapsulation on it. It's a raw device that is mapped directly to this virtual disk for the VM. And so now whatever the guest level formats this with, whether it's NTFS, XFS, whatever file system of choice, that's what will be then formatted on this data vVol. Then when the VM's powered on, a swap is created at the vSphere side of it. And in doing so, a virtual volume is created with a swap type. Now when the VM's powered off, the swap volumes are then destroyed from both the vSphere side of it, that file's destroyed, and they destroy the actual swap vVol itself on the array. Now, the cool part here with how these are individual objects on the array, just like we mentioned before, now when services are then applied to each one of these individual objects themselves, they filter up directly to the virtual disks or to the VM's configuration itself. So when I want local snapshot protection, or if I want to apply QoS, I don't have to apply QoS to my config because I'm not too worried about the IOPS and bandwidth that are going to it, but maybe I want to make sure that this one has QoS applied to it so that it's a limit of 1 GB per second total bandwidth that can send to it. And so then that can be applied directly to that virtual disk. So you have that granular control of your storage and the configuration at that individual virtual disk and VM level. It's something that's going to come up a lot because this granular control of your storage from a vSphere side of it is a large part of the advantages that vVols provides end users. And a large part of where we're able to actually get these array features being used at an application level.